This is a video about how I ended up doing tide gate work as a civil engineer. After graduating from high school, I attended the University of Washington beginning in 1979. I took the pre-engineering course curricula and applied to the College of Civil Engineering, where I was accepted. A few of the classes that I took became very relevant later in life when I started doing a lot of tide gate work. I took fluid mechanics, groundwater, open channel flow, coastal engineering. All these subjects were very relevant to my eventual tide gate work. Now, tide gates are a virtually uncovered topic within the field of engineering. I do not remember it ever coming up in any of the coursework I took while in college. I earned my BSCE degree in 1983. Job market was pretty tough at that point in time, so I elected to go back to school and work on my master's degree. My coursework was primarily in the Water and Air Resources Department of the College of Civil Engineering. Took a lot of classes from Dr. Steve Burgess and used him as my thesis advisor. My master's thesis was titled Computer-Aided Solutions to Two-Dimensional Steady-State Groundwater Flow Problems. With this program, you could input various boundary conditions and initial conditions, and it would calculate the stream function and equipotentials and generate a graphic output like what's shown here. I defended my master's thesis and was awarded an MSCE degree in 1985. Years later, someone pointed out to me that the signature at the bottom of my diploma is Bill Gates' mother, Mary Gates. A little bit of trivia. While I was completing the work on my master's thesis, I picked up a full-time temporary job working for the Seattle District U.S. Army Corps of Engineers. At the time, there was a hiring freeze, and they couldn't hire me for more than 1 year. I got off to a pretty good start with the Army Corps of Engineers. In 1985, I was given an official commendation for some work I did. Involved Lummi Bay ebb channel historical analysis and NOAA current data assessment to predict sediment transport directions and magnitudes. Both of these are somewhat relevant to my tide gate work. Towards the end of my first year of working for the Corps, I was given an award for New Employee of the Year, and this was in an era, I believe, when skinny ties were in fashion. This was around the time when the Seattle District got their first Intergraph CAD system. I was one of a handful of designers/engineers who took it upon themselves to get accounts on the CAD system and teach themselves CAD, and by 1987 I was officially recognized as a leader in CAD production. The Water Resources Development Act of 1986 included lines for a project at South Aberdeen and Cosmopolis. The Seattle District Corps of Engineers had been looking at a flood control project there for decades. It had been taken to a feasibility level design, and with the Water Resources Development Act, we could now take it to the General Design Memorandum and Plans and Specs. This flood control project required a permit from the Department of Fish and Wildlife. Being the lead designer, I met with a fellow named Bob Burkle of the Montesano office of the Department of Fish and Wildlife. He very patiently explained to me all the negative impacts of traditional tide gates as far as fish passage and water quality and wetland impacts and things. And he made a very strong impression on me, and I set about to satisfy his desire to have a fish-friendly tide gate. What Bob wanted was a tide gate that was open most of the time, but only closed when needed to prevent extreme water from flooding the protected area behind the levee. I relayed these requirements to the people in the Department of Hydraulics and Hydrology, and they shook their heads and said there was nothing in existence that did that. I spent the next week or two envisioning what a tide gate like this might look like, and made a CAD model of it and showed it to some people in H&H. They showed it to their boss. Chief of the section is Larry Merkel. He thought it was a pretty neat idea and wrote a memo to Portland Division asking permission to proceed with the design and present it to the project sponsor, the City of Aberdeen. It's a long story, so I won't go into it here. But years later, I learned that Larry Merkel was nearly fired and got in a lot of hot water over this memo he composed to Portland Division. The design that he came up with involved hinging the gate on the side rather than on the top. That allowed it to open very easily with a little bit of flow. And it had what I call a hinge tube that allowed me to control the movement of the gate with a hydraulic cylinder that acted on an arm welded to the top of the hinge tube. Forrest Brooks and I made a trip to Aberdeen to meet with the city engineer, Mr. Ron Marilla. Ron is a great guy. I patiently showed him how the thing would work and went over the CAD model and answered his questions. After I finished explaining the tide gate to Ron, he looked at me and made a wry smile and said, It's kind of Rube Goldberg, but I can't see why it wouldn't work. So he gave it his blessing, and we took it to GDM and plans and specs, and actually built 5 working copies of this out in the city of Aberdeen. The concept for the tie gate was all mine. I did get a little bit of help from other folks in the office. Ed Zapel suggested using Plastifab's copolymer encased steel for the gate leaf piece. Sven Lee made a great idea of including a vent in the top of the culvert in case the gate slams shut. You don't have a potential water hammer event. I did all the CAD work, but the sheets showed up in the mechanical section of the drawings for the plans and specs, and being that I wasn't in mechanical section, we put Hugh Markey's name as the designer. Now, Hugh's a great guy. He doesn't do any CAD work, and he basically just wrote the spec based on the hydraulic components that I had picked out from catalogs on the title block. It's kind of a funny thing. In July of 1988, I was awarded another commendation for my work at the Corps. This was for my work revising the drainage structure tide gates for the South Aberdeen Cosmopolis flood control project. Quigg Brothers was the low bidder, and they won the contract, and the project went to construction in June of 1995. I wasn't able to attend the groundbreaking. My wife gave birth to our 3rd child within a day or two of the groundbreaking ceremony, so I missed that. But I spent the next year and a half living about 2/3 of the time in a motel room in Aberdeen. And I was overseeing construction and answering questions, RFIs, writing contract mods, and it was a great experience watching a project that I designed actually get built. Some great folks on the construction team. This photograph is John Quigg, the owner of Quigg Brothers. And to the right of me is Bill Foster. He was the project superintendent. They were really great people to work with. The construction of the project went extraordinarily well. There were no lost time injury accidents. The cost growth was, I believe, under 3%. We finished the project on time, and my tide gate design worked great. Based on the feasibility level design, which is the design I started with, the Water Resources Development Act authorized a maximum project cost of $28 million. When we were all said and done and had the project completed, the federal cost was about $11 million. So I saved the government $17 million. What do you get when you save the government $17 million? Getting some money or a pay raise would have been nice, but I did win the Engineer of the Year award, which is a pretty big deal. I think I'm more proud of my tie gates than I am of my plaque. It was a real challenging thing to come up with, and a lot of fun to make it work and see it in operation. And the city of Aberdeen eventually wrote me a letter telling me how pleased they were with how they worked. I think this was one of the best things I designed in my engineering career. I showed that I had some competence for working with contractors and overseeing construction projects. So construction division asked me to work for the Fort Lewis area office and be involved in the C-17 bed down program at McChord Air Force Base. This was a huge program. I think there was more work at McChord Air Force Base than all the other military installation for the Seattle District combined. It was about a quarter of the entire workload for the Seattle District. I was the project engineer responsible for the deployment facility, the maintenance training facility, a flight simulator addition, the avionics shop addition, the hydrant system on Delta ramp, the renovation of hangars 3 and 4, the engine shop, and renovations at the machine shop. The hydrant system on Delta ramp was a very critical project with no float in the schedule. The contractor, Porter Brothers, encountered the water table while excavating for a valve vault. I wrote a mod for some pumps, but the transmissivity of the soil was so high that they couldn't draw down the water level at all. To keep the project on schedule, I spent that afternoon and evening in the contractor's trailer with the project superintendent, Dennis Milligan, redesigning the piping and valve layout so that it could be built in a shallower vault. Apparently my vigilance was noticed and letters of appreciation were sent from the commander of the 15th Air Force to the commander of the Corps. I was pleasantly surprised to get a note from my commander, Colonel Rigsby, along with copies of these letters. The entire construction program at McChord Air Force Base was going very smoothly, which is remarkable considering how many projects were under construction. The Seattle District U.S. Army Corps of Engineers was named Air Force Team Award for Construction Agent of the Year, FY 1999. In August of 1999, I was named the PM Forward for McChord Air Force Base. As the PM Forward, I kept tabs on all of the McChord projects, and I was in regular contact with the base wing commander, Colonel at the time, Raymond E. Johns. Prior to me being named the PM Forward, the Corps staff reported to the base civil engineer, a lieutenant colonel. I didn't even know who the base commander was. The base civil engineer was not happy with the arrangement, and he let me know about it. At times he made things very difficult for me. It wasn't long before I wanted out. I quit the Corps in August of 2000. Karma is a funny thing. I learned that just a few months after I left, the base civil engineer was a scandal of some kind and was sent to Leavenworth, the one in Kansas. Later on, I was a bit disappointed to learn that the Corps really did nothing to promote my tide gate design at other sites, and there are literally thousands, if not tens of thousands, of Corps of Engineer levee projects that could use the tide gate to improve environmental conditions and fish passage. Department of Fish and Wildlife also just sort of forgot about it, and it went into obscurity.